All right, we've used completing the square to convert from standard to vertex form, and now we're going to use completing the square to actually solve for some specific values. Let's start with an example, 3x squared plus 6x minus 6 equals 3. Now, before, when we just had y equals, we didn't do anything to the other side of the equation because that was y over there. We wanted it all to stay together. This time we're going to do a little bit of rearranging that might actually help make it a little more sense. So because we're solving and we're trying to get x by itself, the first thing we're going to do is we're going to move this 6 out of the way. Okay? And we're going to rewrite 3x squared plus 6x. Leave your space you've been leaving, and now it equals 9. Okay? So minor shift in approach. We're going to go ahead and start isolating x. But then when I get here, this 3x squared plus 6x, I don't have the tools to just solve for that so far. So we're going to use completing the square. Just like before, I have to divide this a value off to make it 1. So we're going to rewrite 3 times x squared plus 2x, still going to leave the space, equals 9. And then that's the b value we're going to have. So when I do half of 2, I get 1. So I can write x plus 1 squared. I'm going to bring down the 3. And then it's the 1 squared that goes back in. So we're going to plus 1. But what I do to this side, I have to do to the other side. Before, we were subtracting it back out on the same side to keep it balanced. Now we're just going to apply what we know about equations. I did it here, so I have to do it here. So I'm going to add my 1, but I'm not just adding 1 because I had this 3 multiplier over here. I'm adding 3 times 1. So I'm going to include that in there. Now when I do that, equals 9 plus 3 times 1 is 12. It kind of even looks like vertex form at this point. This is just on the wrong side. But we're ready to, we can solve from here because this is stuff I can handle. First I need to divide by that coefficient. Get rid of the 3, divide by 3, and now I have x plus 1 squared equals 4. To undo the squared, we take the square root, and I'm left with x plus 1 equals, the square root of 4 could be positive 2 or negative 2, because negative 2 squared is positive 4 and positive 2 squared is positive 4. So at this point, we're going to rewrite x plus 1 equals 2 and x plus 1 equals negative 2 and finish solving from here. Subtract 1 from both sides. X can equal 1. Subtract 1 from both sides, or x can equal negative 3. Okay. 2 more examples. Let's look at x squared minus 8x plus 11 equals 6. Okay, so we're going to move the 11 and rewrite x squared minus 8x equals negative 5. My a value is 1. I don't have to divide anything out. So we're going to take half of negative 8, and that leaves me x minus 4 squared. 4 squared is 16. I added 16 here, so I have to add 16 here. So x minus 4 squared equals 11. Okay. When I take the square root of both sides, I'm going to end up with x minus 4 equals, well, the square root of 11 is irrational. I can't approximate it with a decimal, so we're just going to leave it and say that it's either positive or negative square root of 11. Plus or minus is sometimes what gets said. Okay. Now, since I can't simplify this anymore, we're going to leave it, and instead of splitting it into two equations at this point, we're just going to move the 4. And I know that x equals 4 plus or minus the square root of 11. There's two answers in there. One of them is the value you get if you do 4 plus the square root of 11. The other one is the value you get when you do 4 minus the square root of 11. And either way, they're going to be nasty decimals, and this is the most exact way to talk about it. So we're going to leave it right like it is. Okay. Last example. 6x squared minus 8x minus 28 equals 2. Okay, so we're going to move the 28 to the other side. And now I've got 6x squared minus 8x is equal to 30. Divide the 6, because I have to have a 1 there. When I do that, I get 6 times x squared minus 8 over 6. Again, that's not going to divide nicely. It is a clean-ish looking decimal, but we're just going to simplify the fraction. Okay, it's going to be 4/3 x, leave some space, still equal to 30. Now, be careful, because when you're multiplying here, half of negative 4/3 is negative 4 over 6, which means I can write that as negative 2/3. So we're going to write x minus 2/3 squared. Bring the 6 down. When I square that, I get 4 over 9. But again, when I add that back over here, it's not just 4/9, it's 6 times 4/9. Okay? So I end up with 30 plus 24/9. And at that point, I completely recommend pick up your calculator and just crunch it. 6 plus, use the fraction function, 4/9, and I'm going to get, well, 6 plus, I get 58/9. I don't want that. I want 30 plus plus 24/9 is 98/3. Okay. And we're going to go ahead and solve. Don't panic yet. It's just fractions and you have a calculator. So divide by 6. X minus 2/3 squared. I can't do anything to clear my fractions because that's in parentheses. I could have done it back here, but we're just going to run with it for now. Okay, so I've got my 98/3 divided by 6. It's 49/9. Okay, but here's why it's okay that we have fractions. Because now we're going to take the square root of this, and x minus 2/3 equals, well, when I take the square root, 49 is a perfect square, that's 7. And 9 is a perfect square, that's 3. And it's still plus or minus. Okay. This might be a really good time to go ahead and clear fractions. I've gotten rid of all my exponents. We don't have to do any square root or anything anymore. So I'm going to go ahead and go through and multiply by 3. So that my equation now says 3x minus 2 equals plus or minus 7. Okay. And this is easy to work with. So here we're going to split this into our two equations. And I'm going to work off to the side, sorry. So we're going to write 3x minus 2 equals positive 7, and 3x minus 2 equals negative 7. Add 2. 3x equals 9. So x could be 3, or 3x equals negative 5 divided by 3. X could be negative 5/3. Fractions are perfectly okay. It can get a little tedious. We're going to look at several methods for solving. Some of them are going to be more straightforward than others. And just like with systems, by the time we get to the end, you can pick whatever method you like the best. I just want you to have experienced all of them so you're making an informed choice.